Welcome to the ZigBee Wireless Networking module. In this section, we'll be covering an introduction to ZigBee. ZigBee networks operate in a mesh topology, which enables devices to communicate and transfer data with each other without the need to send all data through a central device. Mesh topologies enable communication through many different pathways, providing alternative paths if a device falls offline or is blocked in some way. Though ZigBee mesh networks are used in a variety of applications, Control4 uses a version of ZigBee mesh technology called Control4 ZigBee Pro. Control4 ZigBee Pro is a specialized application of ZigBee that offers effective control for our lighting and other ZigBee-enabled devices. This Control4 ZigBee special sauce is a purpose-built flavor of ZigBee that enables devices to communicate with and receive data from our automation system. The Control4 ZigBee Pro design includes a software application called the ZigBee Server, or Z Server for short. The Z Server receives communication from Director and prepares it for transfer to the ZigBee mesh network. ZigBee messages are broadcast from a radio antenna named a ZigBee Access Point, or ZAP. The Z Server and the ZAP should be activated on the same Control4 controller. When this happens, that controller becomes a mesh controller. Communication in a Control4 ZigBee Pro mesh network begins at Director and then moves to the Z Server and then to the ZAP. There are two types of nodes, or devices, that exist in a ZigBee mesh network. Router nodes are able to receive ZigBee signals and transmit them to other devices. They are usually actively connected to power, enabling them to receive and route signals to other devices continuously. End nodes are generally battery-powered and do not route ZigBee signals to other devices. Router nodes include Control4 lighting devices, configurable keypads, and Z2IO devices. End nodes include SR260 remotes, thermostats, motion sensors, and third-party ZigBee devices. Here's an example of how a Control4 ZigBee Pro mesh network operates. A packet intended for the thermostat end node in this network starts at the mesh controller, is sent to a routing lighting device, and then to the thermostat. Control4 ZigBee Pro contains self-healing features that make it a preferred choice for automation devices. Watch how this works. If a router node falls offline for some reason, ZigBee packets can be routed to the next nearest neighbor so that they can still reach their destination. To begin creating a ZigBee network, a Z server and a ZAP are enabled on the same controller. That controller is now a mesh controller. After the ZigBee mesh is fully enabled, the ZigBee devices in the project need to be identified. When you identify each ZigBee device, an identification address appears in the ID window in Composer. This address is a permanent physical address and is unique to each device. It is called a MAC address. What you do not see is that the mesh controller issues an encryption key to each device it identifies, ensuring that packets intended for it are routed to the correct destination. ZigBee devices closest to the mesh controller should be identified first. When this is done, end node devices can make connections through routing nodes and establish the mesh network. Each ZigBee device has its own unique identification process. For example, the SR260 is identified by pressing the red 4 button 4 times, while the thermostat is identified by pressing the humidity button 4 times. One important note: when a device identifies to a mesh network, the mesh controller initiates a firmware update to that device if needed. As part of the update, the device may power cycle, and if it is a lighting device, toggle its load. The update process throughout an entire project may take a couple of hours to complete and is no cause for alarm. You now have a working knowledge of how ZigBee operates. Time for the quiz.